Now, let's look at question number 2, page 87, practice 3.1 from General Chemistry course book, TST 0914. So, how to answer question number 2? Okay, the question asks you, give you the frequency of the line spectrum in Lyman series. Okay, let's highlight the Lyman series. Okay, with a frequency 2.46 times 10 of 15 per second. Okay, so A question asks for the value of N1 and value of N2 that produce this line. Okay, so how to answer? Firstly, for Lyman series, okay, we have N1. Okay, Lyman series is N1 equals to 1. Okay, so for A question, okay, how to calculate the value of N2? Okay, for Lyman series, the N1 is 1, the ground state of Lyman. Okay, so to calculate the value of N2, we need to use the value of the frequency. But before that, the frequency need to be changed to lambda or energy, because only lambda or energy has relation with N values. Okay, so let's say I choose to use the value of energy. Okay, so the delta E is H nu. Okay, so we can calculate. Okay, energy is equals to H 6.6256, okay, times 10 to the power of negative 34 joule second, okay, times with the frequency given in the question 2.46 times 10 to the power of 15 per second. Okay, from there we can get the value of energy, which is equals to okay, it is equals to 1.6299, okay, times 10 to the power of negative 18 joules. Okay, so from the value of energy, okay, we can use the formula delta E equals to RH 1 over N1 square minus 1 over N2 square. Okay, where the N1 must be less than N2. So we can substitute the delta E value 1.6299 times 10 to the power of negative 18 joules. Okay, equals to RH. RH for calculating energy is 2.18 times 10 to the power of negative 18 joules. Okay, times with 1 over N1 square, and 1 is 1 for Lyman, minus 1 over N2 square. Okay, so the answer, the N2 value, okay, calculate using your calculator, it will be equals to 1.99. So this one is round off to 2. So N2 is 2. Okay, so N1 for this question is 1. Okay, this one. And N2 is equals to 2. Next question, it asks us to calculate the wavelength of the spectrum. Okay, so in the question, you are given the value of frequency which is equals to 2.46 times 10 to the power 15 per second. Okay, so this is the value of frequency. So using the value of frequency, we can calculate the value of the wavelength. So frequency is equals to C over lambda. So lambda is the wavelength. Okay, rearrange this equation. We will get lambda equals to C over C is the 3.00 times 10 to the power of 8. Okay, meter per second. Okay, over the frequency value 2.46 times 10 to the power of 15 per second. Okay, so this one can be cancelled. Okay, we will get the lambda value. Okay, the lambda value is equals to 1.2195 times 10 to the power of negative 7 meter. Okay, so this one can be cancelled. Okay, we will get the lambda value. Okay, the lambda value is equals to 1.2195 times 10 to the power of negative 7 meter. Okay, so this one can be cancelled. Okay, we will get the lambda value. Okay, the lambda value is equals to 1.2195 times 10 to the power of negative 7 meter. Actually, the value of N2 can also be calculated from the wavelength values. Okay, so we have calculated just now in B question the wavelength value for this line is 1.21 times 10 to the power of negative 7 meter. Okay, so we can use 1 over lambda equals to RH 1 over N1 square minus 1 over N2 square. Okay, where the N1 is less than N2. Okay, so before this, in the previous part of this video, I have explained how to answer question A using the energy values. Okay, so now I'm going to explain how to use the lambda values, because you are given the frequency. From frequency, we get the value of lambda. So the lambda value can also be used to calculate the value of N2. Okay, so we use this formula. So we substitute. So 1 over lambda, 1 over 1.2195 times 10 to the power of negative 7 per meter. Sorry, meter, not per meter. Okay, equals to RH 1.097 times 10 to the power of negative 7 times 10 to the power of 7 per meter. Times 1 over 1 square minus 1 over N2 square. Okay, so how to get the value of N2? We calculate the N2 will be equals to 1.99, or we can round off to 2. So similar answer, the same answer that we will get for the value of N2 that produce this line. Similar with the method in the previous part of this video. Okay, if you still remember, we have already calculated the value of energy for the formation of this line in this question. The line in this question, which is the transition from Lyman series. Okay, from N2 equals to 2 to N1 equals to 1. Okay, the energy that we have already calculated is in joules, okay, which is 1.6299 times 10 to the power of negative 18 joules. Okay, this question asks in kilojoule per mole. So I'm not going to show you how we calculate the delta E anymore. You can refer to the previous video. Okay, part of this video. Okay, so to change the unit from joules to kilojoule, okay, so to change it to kilo, we have to times with 10 to the power of negative 3. Okay, and then to change it to per mole, we times with the Avogadro's constant 6.023 times 10 to the power of 23 per mole. Okay, so the answer will be 981.6888 kilojoule per mole. Okay, so that's the answer for question number 2. Okay, same practice 3.1. Okay, page 87. But now question number 3 in General Chemistry course book TST 0914. So how to answer question number 3? An electron of a hydrogen atom is excited to the energy level N equals to 6 and drops to a lower energy level, forming Lyman series. Okay, so that's the information that we have in this question. Okay, so Lyman series N1 is equals to 5. Okay, so excited state is N equals to 6. Okay, and it drops to N1 equals to 5. So for question A, Okay, it asks us to state the energy level whereby the electron drop back. Okay, so we refer to P1 series. So the energy level whereby the electron drop back is N1 equals to 5. Okay, the ground state of P1. B, calculate the energy of the electron at the excited level. Okay, so the excited level is N equals to excited level is N equals to 6. Okay, so to calculate the value of energy, we use the formula En equals to, okay, we want to calculate it at N equals to 6. So E6 equals to negative RH 1 over N squared. Okay, so En equals to negative RH 1 over N squared. So we substitute E6 equals to negative RH. So negative RH here, because we want to calculate the energy, we use negative 2.18 times 10 to the power of negative 18 joules. Okay, times with 1 over 6 squared. So you will get the answer. Okay, the answer is negative 6.0556 times 10 to the power of negative 20 joules. Okay, the negative sign in front of the energy value here means the energy is released. Okay, energy is released. Okay, so that's for B. So how to answer question C? Okay, question C asks us to calculate the energy emitted as the result of the transition. So transition that we have here is from N equals to 6 to N equals to 5. So to calculate the energy, we can use the formula delta E equals to RH 1 over N1 square minus 1 over N2 square. Okay, we substitute the value of RH 2.18 times 10 to the power of negative 18 joules times 1 over 5 square minus 1 over 6 square. Okay, the answer will be 2.6644 times 10 to the power of negative 20 joules. Okay, so that's all for practice 3.1. Thank you.